So one last thing I want to sort of introduce to you is we've got all these functional groups. So I'm going to draw this molecule. Okay. We've got an aromatic group there. We've got an alkene here. We've got a nitrile over here. We've got an acid, carboxylic acid over here. We've got a secondary amine here. We've got an alkyne over here. We've got an alcohol over here. We've got a carbonyl down at the bottom, make it a ketone. And I'm just going to put in a hydrogen there. Usually we don't show hydrogens, right? So this is our molecule. But let's look closely. Yes, this is a carboxylic acid, which I'm going to label in red, like so. And this is an alkyne, yes. And this is a secondary amine. And this is a ketone. And this is a secondary alcohol. And this is an amine, or aromatic. And this is a nitrile. And this is an alkene. Fantastic. So we've got all those bonds. And we know they're all polar because of what we've seen in earlier lectures. So that's all good. Now what we also need to establish is the fact that, yes, this contains C double bond O. And this contains a CO bond and an OH bond. And this contains a C double bond O and an OH bond and a CO bond. And an alkyne contains a C triple bond C. And it contains a CN bond and an NH bond. And this contains a C triple bond N. And this contains a C double bond C. So all of these bonds, and then I guess I should remind you the CH bond, all of these functional groups contain specific bonds, okay, which are hopefully you can see in blue there. We'll scan in. Wow, don't get too close, it's toxic. So we've got all these bonds, and these bonds correspond to certain absorptions in the infrared spectrum. Okay, and I'm going to write these on the table on this molecule to show you that yes, when you look at a molecule and you see certain absorptions, that's a function of certain bonds. So if you have an unknown, you get certain absorptions, it can suggest that, okay, if I have an example, which I'll come to in a minute, you can identify the functionality or certainly imply that it's one of 3 as opposed to the 20 we've already seen. So remember, we're going to see wave numbers. And these wave numbers go from 4,000 to 400 centimeters to the minus 1. So the numbers you'll see are wave numbers, the units are centimeters to the minus 1, in case I forget to add those in. So I'm going to make those in purple, just to keep you focused on color. Little intense. So a CH bond is 2850 to 2960. A C double bond O can be anywhere from 1650 to 1780. I guess I should put centimeters to minus 1. A CN bond can be anywhere from 1030 to 1230. An NH bond is anywhere from 3300 to 3500. A C triple bond C is anywhere from 2100 to 2250. Hopefully you can see that still in much. A CO bond is anywhere from 1050 to 1150. An OH bond is 3500 to 3300. C double bond C is anywhere from 1600 to 1650. So it can be anywhere from 1600 to 1680, shall we say. And that's true for this one here, 1600 to 1680. And the nitrile is generally very sharp. And this is between 2150 to 2160. It's a very tight range. So now, we've got the carboxylic acids. Okay, you've got the carbonyl of the acid, which is going to be between 1650 to 1780. The OH, which is 3500 to 3300. And the CO, which is 1050 to 1150. So you may have to expand your screen to see those. I apologize. There we go. Slide it all in. So you can see not only now we've got the functional groups, we have the bonds, and now we can see the absorptions and stretches. So that helps us a lot, because if we have an unknown, okay, and say we have an unknown that has an absorption, say at 1680, so the absorption, let me write this, for the unknown, 1680, and excuse me, we also have 3300 centimeters to minus 1. So we've got two absorptions there. From our knowledge based on our structures, we know so far